Well, we're nearing the end of Unit 3. The last topic that we want to cover, and then we'll do some practice worksheets, is Section 3.14, so 314. I can multiply and divide square roots. So go ahead and write the word square here. Everything that we deal with today will be using square roots. So a quick warm-up here. Again, we mix things together all the time. It's important to keep in mind how to do these, because these are going to continue to come up and they'll definitely be on the test for this unit. So we're going to solve this. This is a quadratic equation, remember, because it's got a square in it. So we're going to add 10 because we want to isolate that square. Those are going to undo each other, so we end up with 4x squared on this side. We end up with a 100 over here. It's still not isolated, so let's keep isolating that. We're going to divide both sides by 4. So this is going to be x squared equals, and then 100 divided by 4. Let's see, if you took $1 and divided it into 4 pieces, you'd end up with 25 cents. So that's a 25 there. And then, of course, we're going to undo the squaring. Again, we're going to say this the right way. We're going to say we're going to take the square root of both sides. So when we take the square root of both sides, the square root undoes the squaring. And then over on this side, we have the square root of 25, which is just 5. Now, I'm going to put a circle around this, and I'm hoping that some bells are going off on this problem, because when we take the square root of a number, we have to put a plus or minus on there. When we're solving an equation and we put the square root on the problem, we have to put a plus or minus on there. So please make sure that you don't forget that. Okay, now in today's section, when we're talking about multiplying and dividing square roots, that might sound like it's really complicated, but there's some really cool properties that we can use when we're multiplying and dividing radical expressions. Now, I've got the product property right here, and I've got the quotient property illustrated right here. I do want to make sure we're all aware of what a product is and what a quotient is. So remember, a product is, we're just going to write a multiplication problem. Multiplication problem. Now, you may be aware that a product is the answer to a multiplication problem, and that's it can also be used that way. So if we say a product, it might be talking about the answer to a multiplication problem or the multiplication problem itself. And the next one is, what is a quotient? Well, a quotient is a division problem. So when we talk about a quotient or a product, we're just talking about multiplying and dividing in one sense or another. So here's the product property. The product property is this really cool property that works with radicals, and it works like this. So we have a multiplication problem underneath the radical, and the product property says this: if you've got some big ugly multiplication problem underneath the radical, what you can do is you can find the radical of the first factor, okay, the radical of the first part, and the radical of the second part, and then you can multiply them together. So it's almost like you break this, it's kind of like distributing, if you want to think of it that way. So we break this into two pieces, we find the answer of those two smaller pieces, and then we multiply those answers together. And the cool thing is it works exactly the same way with the quotient property. Here I've got the radical of a fraction, radical of a quotient, a division problem right here. And what the quotient property says is, rather than finding the radical of this ugly division problem, let's find the radical of the top and the radical of the bottom, and then we take care of the division after the fact. Now, what I'd like you to notice is these rules work in both directions. So if you have the product of two radicals, you could put them underneath one big radical if that was better for you at the time. And if you've got a radical on the top and a radical on the bottom, you can put them underneath one big radical and do the division inside. So these can be used in both directions. Now, what we're going to do today is we're only going to be using the product property today. We're going to be focusing on this one right here, and we're going to be using it in both directions, so please keep that in mind. It usually is used more often, taking a product underneath and breaking it into some small pieces, so kind of keep that in mind. But it does definitely work if we put those together, okay? So they both work really well, and we're going to focus on this product property of radicals. So I'm going to slide down here. And we're going to take a look at this one here. So we've got radical 6 times radical 3. Now, think of it this way. We always want to make sure that we're simplifying radicals. And there are lots of different ways to do these and lots of different ways to think of these, but this is the interesting part. Remember, we always want to simplify the answer, and when we're simplifying square roots, we're looking for pairs of factors. Well, this is a 2 times a 3, so I'm going to go ahead and write that down. I'm going to write down 2 times 3, and then times radical 3. Well, you'll notice that there's no pairs of factors here, and there are no pairs of factors here. So we really can't simplify either one of them all by themselves, but if we use this product property, and in this case we're using it in reverse, let's put them both underneath the same radical. So we're going to put them underneath the same radical, and we're going to have the 2 times the 3, that's a 6, times the 3, there's the 3, and now we have a pair of 3's. Notice that we got one 3 from the 6 and we got the other 3 from the 3. So now I can take a 3 out, there's a 2 left underneath, and that's simplified. Definitely simpler to write this than it is to write that right there. Okay, let's do another one. Again, very similar. So here's what we're going to do. I'm going to take a square root, and this would be 6 times 18. Now notice I'm doing this one a little bit differently. I'm going to keep the square root, and I'm going to do 2 times 3, and then I might do 2 times 9 or something like that, but I'm going to do it this way. 18 would be 3 times 3 times 2. So take a look here. This is the 6, and this is the 18. Now I'm going to erase those lines in just a second. 2 times 3 is the 6. 3 times 3 is 9, times 2 is 18. So I've got everything all written down here. Now I did that on this one for a reason. I've grouped a couple of the 3's together, so I'm going to pair those together, and I'm going to pair these together. Now these are not next to each other, so I kind of like doing something like this. So I'm going to have a 2 on the outside to represent that pair of 2's. I'm going to have a 3 on the outside to represent that pair of 3's, and then I've got that 3 stuck underneath. So the answer on this one is 6 radical 3. I'm going to circle that and we're all done. Now I am going to change this and change colors, and I'm going to do this a different way. Another way to do this problem would be to do this. We could write radical 2 times 3. This isn't simplified. We could write that as 3 times radical 2. Now think about why we could do that. Because remember, this is 3 times 3 times 2. So I can take out that pair of 3's, put it on the outside, and then notice that I've got a 3 on the outside, a 2, a 3, and a 2. So notice that this was stuck underneath and this was stuck underneath, because in each one of those individual radicals we didn't have anything that we could pair up. And now I've got a pair of 2's underneath the radical. So we've got a 3 here, we've got a 2 from that pair, and the 3 stuck underneath. So we have 6 radical 3 again. So either way you want to do it is fine. I kind of like this better. I kind of like putting underneath one big radical and then grabbing the pairs of factors. So let's take a look at this one. Again, I'm going to change colors again. So if we take a look at this guy right here, I'm going to do a big radical, even though I know I could simplify each one of those separately. So here's what I'm going to do. I'm going to do 2 times 3 times 3. There's the 18. That's 2 times 9. And then I'm going to put times. 12 is 2 times 6, which is 2 times 3. So again, I'm going to underline these just so you can see them, and then I'll get rid of this in just a second. So this is 2 times 9. There's the 18. This is 4 times 3, there's the 12. So I do have all of the factors underneath there, and then again I'm simplifying a square root, so I'm looking for pairs of factors. So I've got a pair of 3's, I've got a pair of 2's, so we've got a 3 and a 2 on the outside, and then let's see, there's nothing else to pair up, so we're left with a 2 and a 3 on the inside as well. So we have a 6 on the outside, and lo and behold, a 6 on the inside, so we get 6 radical 6. Again, I'm kind of a fan of this right here where we just write out all of those factors. And again, there are lots of different ways to do these. Find a way that works and then just stick with it. So let's take a look at this one. You'll notice that these have coefficients out in front. This one is simplified completely, so this is 3 radical 3. This one is we've got a 2 and then 27. We've seen that a couple times before. Good thing to remember that 27 is 3 cubed, so I've got 3 3's there. So I'm going to write the 3 and the 2 out in front, and then I'm going to put everything underneath the radical, either here or here, underneath one big gigantic radical. So I'm going to have 3 and 3 and 3 and 3. So again, square roots, we're looking for pairs of factors. So I take that out and that out, so I have a 3 times a 2. I've got another 3 and another 3, and notice that we've taken everything out so there's nothing left underneath. So this is going to be 6 times 9. So lo and behold, we have that ugly mess, and we end up with a nice answer like 54. Okay? All right, now you could, and I'm going to change colors for this, you could, if you wanted to, do this. I'd write the 3 and the 2 outside, And then I'd just go ahead and write down the 3 from this first one, and then you can write down the 3 3's from the radical 27. That would save you a little bit of work, at least one line of work. But again, same answer either way. We have a 3 times a 2 times another 3 times another 3. So same answer either way there. Okay, just keep that in mind. All right, let's take a look at this one. We've got a dot right here, so that is multiplication. I am going to do this one the way that I just mentioned, so here's what I'm going to do. I'm going to do the 3 times the negative 2. Okay, I guess I don't need the dot there. And then I'm going to do a big radical, and I'm going to do 20. 20 is 4 times 5, so I'm going to do 2 times 2 for the 4, and then a 5, so there's the 20, and then I've got another 5 from this guy right here. So we end up with the same thing happening here on this one. Everything comes out. So we've got a 3, we've got a negative 2, we've got a 2 from that pair of 2's on the inside, we've got a 5 from that pair of 5's on the inside, and then nothing left underneath except for a 1, so technically the square root of 1, but we don't have to write that. So this is a negative 6 times a 10, so the answer on that one is negative 60. All right, so we're all set to go. Now, I do have a couple more that I want to take a look at. This one is like one on your assignment. So if we were to take a look at that right there, again, I think the best way to do these is, and if you wanted to write down what negative 9 times negative 2 was right off the bat, that's fine. I'm going to go ahead and write down the work. So this is a negative 9 and a negative 2, and then I'm going to write a big square root. That big square root is going to be 14, which is 2 times 7. Times a 2. Now you might notice that if I had written down 7 times 2, the 2's would be next to each other. It's not that big a deal. I just write a big, kind of a big ball around the 2 of those right there. So I have a negative 9 times a negative 2, which let's go ahead and write that down as 18. That's going to make things a little bit easier. So this is going to be 18 times that 2 and then a radical 7. So 18 times 2 is 36. And then we've got a 7 stuck underneath, so this is going to be 36 radical 7 for the answer on that one. Now, I do want to show you a couple ways that you've been actually using this product property without really even thinking about it. And some of you may have caught on to this already and be able to recognize this. So here's the way this works. We should recognize these numbers right here, especially this one right here, the radical 144, square root of 144. Well, I've filled in, I've got some of these blanks, and then we're going to fill in the rest of these. So I've got 144, and then that is 9 times some other number. So if you needed to, if you know what this is, great. If not, that's fine. So we're going to do 144, and we're going to divide that by 9 to see what's left over. So that's going to be 16. So I'm going to put a 16 right here. Well, we know the answer to this is going to be 12, but take a look at how this product property works out. We have a multiplication problem underneath here. So we're going to break that into 2 little radicals. A radical of 9 times the radical of 16. Radical 9 is 3, and radical 16 is 4, and lo and behold, again, the radicals went away, kind of like some of the problems that we did a second ago, and we end up with 3 times 4 is 12. So there's the answer, and that's another way of knowing that the square root of 144 is 12, and another way of kind of applying the product property of radicals without even thinking about it. Some of you may have been doing this for a while now as we've been simplifying these. We learned how to do these at the beginning of the unit, and you may be pretty good at these right now and have been using this without even thinking about it. So let's take a look at this one right here. This says radical 225 is a little multiplication problem times 25. So if you think about it, if you had $2.25, you would have 9 quarters. So that means this would be the square root of 9 times the square root of 25. And again, notice how this little property allows us to take this big ugly number and break it into numbers that are much smaller and much easier to work with. So the square root of 9 is 3. Square root of 25 is 5. So we multiply those together and we end up with 15. And you may recognize the 225 is a perfect square of 15, so perfectly good answer there. All right, everything on today's assignment is using the product property, so we're multiplying radicals and then simplifying from there. Good luck on the assignment.